Welcome everyone to my presentation on zero-valent iron used for environmental remediation. So, zero-valent iron, as we all know, iron is a very, very abundant mineral, and which makes it very cheap. And in its mineral form, most of the time, iron has zero valence electrons. So, when purified, you get zero-valent iron. And what makes zero-valent iron special is this number right here. That is its standard reduction oxidation potential. And what that basically means is that it is a very, very strong reductant. It will reduce almost anything, and it wants to be oxidized. But not only will it reduce the strong oxidants, such as oxygen, as shown up here to the right, but it will also reduce some things that might not be great oxidizers. And those are going to be the contaminants that we're actually going to try to go for. So some of those contaminants include polychlorinated ethylenes, which those are very, very commonly found around dry cleaners. And then you have heavy metals such as chromium-6 and arsenic. And those in oxidized forms can be very, very toxic. But once when they are reduced by zero-valent iron, they become not toxic, which is really, really great. The zero-valent iron can reduce nitrate to ammonium, and then you have nitroaromatic compounds, which an example of that would be TNT. Those are just explosives, so whenever those need to be remediated, those can be reduced also to safer forms. Things get crazy when you actually talk about trying to use zero-valent iron to dyes or phenols, which is a common pharmaceutical base. This happens with the presence of dissolved oxygen, and what you get is you have hydrogen peroxide as a byproduct, and then that will eventually form a free radical hydroxide ion. And that is actually the opposite of ZVI. That's a very, very strong oxidizer. And so it sounds very, very crazy, but it can actually be used to treat some of those other contaminants. And like this figure actually shows right here, it can be used to reduce the original nitroaromatic compounds and then take its byproducts. And once when hydrogen peroxide is present, oxidize those to get complete removal. So how does it actually work and how is it actually used? The two most common ways of using zero-valent iron in groundwater remediation is through a permeable reactive barrier, which is seen right here in the top left. And a real-life construction site of this is right here. And that is just literally making a wall of zero-valent iron and making the groundwater flow through it to react to it. And then the other option is you have an injection well, and then you'll slowly inject zero-valent iron with this zero-valent iron slur, and over time as groundwater passes, you will inject it in to react with it, which is really, really cool. There are some more modifications you can do to that. You can attach something very, very dense and heavy to zero-valent iron if you're really trying to attack a DNAPL, and that will just make sure whenever you inject it, it will go to the bottom of the aquifer and get that contaminant. It's also been seen before where people will attach or react organic compounds to support bioremediation along with zero-valent iron reduction. And additionally, it's been seen to people have put adsorbents in with zero-valent iron to make sure that there's complete reduction going on. So there are modifications, but primarily it's going to be these two permeable reactive barriers and injection wells that are going to be used with zero-valent iron. Here are my sources, and yeah, thanks for watching, everyone. Let's see.